Hello and welcome. This is episode 97 of eCHO, and today we're going to be talking about some of the upcoming features around Gateway API. Today, I would really like to welcome Shane, who is joining us from Kong. Thank you very much for taking the time out of a no doubt busy day to come and join us and help us understand a little bit more about kind of the things that you've kind of been driving.
Yeah, no problem. Thank you for having me.
Cool. So for people that maybe meeting you for the first time, could you give us a bit of a quick intro into kind of who you are, what you're working on, Kong, the company that you're working for, and things like that?
Yeah, sure. So I am currently a staff software engineer at Kong, and my road came from my early days of my career started in data center tech. So way long ago, I was working on provisioning systems, working with KVM, Zen, and got into networking. Not going to say how long ago, but it's been a while. And
the mention of Zen kind of made me hark back to a distant past.
Yeah. There's a lot of Zen in my history, but so anyway, that led into networking, and networking kind of became a huge thing for me. Probably long before Kubernetes. So I was working with Cisco's Nexuses and Arista and all that kind of stuff, and programming those and writing software for those in a data center kind of environment. And then Docker came around, containers started getting really big, and Kubernetes came around. And at that same company, we started building a product called Managed WordPress on top of that. And that was the beginning of my Kubernetes story. We were using Kubernetes right as soon as it landed, and when nobody should have been using it. And basically the story kind of unfolds from there. But I've been working on networking in the Kubernetes space since then. As my primary focus. It's not the only thing that I've done, so I'll spare the details from there to here. But currently, I work on networking at Kong, Kubernetes networking. One of my main projects is our Kong Gateway operator, which is currently in technical preview, which is responsible for it's a Gateway API driven ingress controller is the simplest way you can look at it, but it's an operator, so it has autopilot features around ingress networking. Yeah. And then I think the more prevalent thing for the audience will be my work in upstream. So I lurked upstream for years, but I worked at companies where it wasn't really kind of pushed to go actually work in upstream until Kong. Kong's been very, very much in favor of having me kind of work with the upstream. So as soon as I started at Kong, I was already working with Gateway API at my previous job at Mesosphere. And when I got to Kong, it kind of just took off. And I became a maintainer a while ago. I don't remember exactly when. Yeah, I became a maintainer, and been doing that for the last couple of years, and focusing on getting Gateway API to GA, which we're hoping to do in time for KubeCon Chicago this year. And also this year, Casey Davenport, who works over at Tigera, decided he wanted to take a break from being a chair of SIG Network. So that was another thing I picked up this year. Was I took that spot and have been helping out with the chair position in SIG Network since January, February.
Very cool.
Yeah,
that's I couldn't help but kind of find it amusing to a certain degree. So my past, I was automating Cisco UCS Nexus kit. Ended up at HPE automating C7000s and their Synergy platform, which was kind of like a main competitor to Cisco. And then ended up at Docker on a project called InfraKit, which was for automating infrastructure to deploy Docker Swarm and then Kubernetes on top of. So this kind of almost a weirdly
similar trajectory. Yeah.
Cool. Thank you very much for sharing that. A couple of people drop in hello. So hi there, Tony, and hi there, Lacoste, if I'm pronouncing your username correctly. So As I said, thank you very much for joining us. Before we kind of kick things off, as we often do, a bit of an overview of some of the upcoming events at the moment. So we have eBPF Summit, which is coming up in the next couple of months. The CFP is open for another couple of weeks, I think, not too much longer. So if you have content that you want to create around your use cases with eBPF, your journey with eBPF, the things that you're learning, the things that are using eBPF, then that is a fantastic conference for you to submit content to. However, if you're wanting to just learn more about eBPF, a lot of people are talking about it, but not necessarily a lot of people understand what it's used for or how to use it and things like that. Then this is going to be a virtual summit that should be free to join.
Very
Additionally,
cool.
as part of KubeCon, there is Cilium Con, one of the community days. It's going to be a full day at this KubeCon. The CFP is still open for that, along with all of the community days that are taking place at the beginning of KubeCon. And then additionally, there is Civo Discover, which is on the 5th and 6th of September. I saw a tweet recently, if people are still on Twitter, I don't know if they've all migrated to Threads at this point, that there's going to be a special keynote from somebody who's just retired from the tech industry. So that kind of only alludes to one person that I can think of, but I guess they'll announce that in due course. So those are kind of all of the upcoming events that are kind of on our radar at the moment. In terms of recent news, I noticed that Flux has just gone V2. So if you are automating all of the things for your GitOps pipelines, then there is a new version of Flux to upgrade to. There's been a lot of kind of craziness in social media at the moment, kind of all around the Red Hat operating system, the upstream Linux RHEL. So kind of decoupling themselves from some of the downstream distros such as Rocky and Alma. So that's kind of ongoing at the moment. If you are using images from ChainGuard, there has been changes with that now. So if you are not using a paid account, you will only be able to use either the hashes or the latest tag. So if you want to use version tags, the only way to do that is with a paid subscription account. So that's something to be aware of. And last week was the first ever Net DevOps Days event, which was a fantastic event. Really kind of got me out of my Kubernetes head to actually see a lot of talks, mainly focused around kind of automating big stacks of network switches and things like that, which, you know, kind of for a lot of people, they forget that a lot of these tasks still need to take place. And a lot of people are still doing kind of a lot of, you know, kind of that low level infrastructure stuff. So that was a really good event, and all of the videos from that will be on YouTube in the near future. So that's everything kind of that's been kind of on my radar for like the last week or so. Let's kind of kick things off into Gateway API. So, you know, I've got Shane here. So why Gateway API? What's the, you know, what's kind of the main reasoning for it?
Yeah. Well, Ingress is good. Like it does a lot for simple use cases, and it's going to be around a while. But Gateway API is kind of the next generation of it. There were some problems with Ingress, there's several problems with Ingress. I think the biggest of which was probably just the fact that the feature set was so minimal that we ended up in what I often like to call the annotation Wild West, where any one ingress that you have, maybe stored in your configuration management or something, is just not going to work with another implementation because of its annotations and so forth. And the goal isn't necessarily to make sure that it absolutely works between those implementations, but that it's a lot closer to being able to work out of the box, like reduce a lot of the work, if not all of it. For many use cases, Gateway will be in a position where you'll just be able to move it between two implementations because the feature set is so rich. We've spent the last couple of years really going through all the use cases and kind of teasing out all the different nested features that you could possibly put on, say, an HTTP route, which is kind of our premier API and the biggest parallel API to Ingress. There's more to it than that, but that's kind of the long and short of it. It's wrapped up in features and also role orientation. Ingress was kind of this. I mean, we ended up with Ingress class and stuff like that. So like, there's a little bit more than just Ingress, but it was kind of this solo thing that like you just kind of assumed there was an Ingress controller out there, was a proxy out there somewhere that was going to pick it up. It was a little, it was bare bones. I think is probably a reasonable way to put it in some ways, at least from like the role of people who actually do the thing. So like
Mm-hmm.
you had to be reasonably privileged to do any of it, and there was no Kubernetes APIs to like really kind of connect to when it came to the infrastructure part of it. It was just give us your port and your routing information. Gateway API actually has resources like Gateway. So that's a Kubernetes resource that actually reflects the proxy, which used to be just a deployment perhaps that was like kicked off by Helm install. Now there's an actual gateway resources. It has listeners and ports and stuff that you actually attach your routes to and say, my route goes to this port. And so you can do it in what I'll call a more Kubernetes native kind of way. And also you can assign different roles to those. So like you can use RBAC for the gateway, can be, your cluster admin or something can be responsible for the gateway classes. You have like an operator that's a human operator responsible for the gateways, and then the developers can ship their routes, which attach to those gateways. And that gives we've found it to be so far a really nice way to kind of disconnect, like not have it all piled in and like you just one thing that you kind of have to give RBAC access to, and it just lets you drive, everything. So
yep. So it's kind of how I kind of see it, I suppose, like it's in kind of the documentation to a certain degree. We have the gateway class, which is the overarching implementation of the kind of the infrastructure version or the vendor type of the gateway API implementation that we're actually doing. So that's the overarching kind of type of gateway API that we're implementing. Then you've got the gateways, which are deployed by the ops team, and then the applications team would be the people adding the routes in which point to various deployments inside their cluster. Is that?
Yeah. Here's actually, if you don't mind sharing the screen real quick for a minute. This is our website, and this probably gives just a good little overview of what we're talking about here.
Yeah.
Can you see what I'm doing?
Yes.
You see the picture? Okay.
We see the
Sorry.
picture, yeah.
I'm having problems with StreamYard, so I guess it's just me. But okay. So on the top there, infrastructure provider gives you the gateway class. Your cluster operator gives you the gateway. The developers take care of the routes and attach to their services and so forth. So
yep.
That's pretty much it. It gives this breakdown, which actually kind of thinks about the roles that will be involved, and consequently, there's RBAC associated with those roles, which is good.
Cool. Yeah, and so I mean, there's kind of a lot of implementation detail that's kind of abstracted away and not kind of, I suppose, kind of covered here. But for instance, the gateway class as a thing that you implement, that's largely kind of there's not a lot of code that actually goes into what is the actual gateway class. It's
actually going to probably have a little bit more soon, but
okay.
Yes, that's mostly true. To give some tidbits. So in the earliest days of gateway class, it was pretty much like Ingress class in that it was just give us the name of your controller so that we can attach gateways to this. So we know what controller, we'll say controller, you could, you can kind of be whatever you want, but assuming you're like building with controller runtime stuff, your controller that's going to be responsible for all the gateways attached to this class. Actually, it also includes parameters refs, which implementations that I work on actually use to basically influence the configuration of all of the gateways potentially underneath that gateway class. And we're currently working on, before GA, we're hoping to have some status related stuff where the gateway class would actually include a status that lists what features are supported by that controller. So that's kind of on the horizon. I'm working on that with a couple people right now. And a guy named Leor from Google actually, I think, is currently writing the GEP for it, which is basically like the proposal.
Yep.
And we're hoping to have that hopefully before GA, but if not too long after GA, where you'll be able to like, okay, here's the gateway class, you create it, the controller picks it up and says, okay, here's the features I support. Because and we can get into this, but there's basically one of the ways in which we solved the annotation Wild West was we didn't just say everybody has to implement all the features ever known, because that wouldn't work. We did, here's all the features ever known, and here's different tiers of support, including a core one, which is everybody supports everything in core, and then there are other tiers, which basically allows us to have them in specification, but they're not required in order to have them in implementation.
Okay.
So that's why that status would exist.
So when we're talking about features here, are we talking like the type of routes that it supports, or are we talking more about vendor specific?
Routes, potentially, yes.
Mm-hmm.
But we're also talking about like features on those routes. So I'm trying to think of like a good example, but basically like, let's say regex path matching or something like that.
Okay.
Like if that was not a core feature, then it's theoretical that you deploy your gateway operator, your ingress controller, whatever it may be, and it doesn't support that. We want that to be a little bit more clear up front, and potentially something that can be validated. So
Mm-hmm.
that's why this will exist, basically. So it's like, if that isn't something you support, the user doesn't want to figure that out by way of, I try to use it, and then the result of it failing and then putting a status on my route is what I have to tie back to the fact that that doesn't exist. We just want it to be more clear and upfront. Actually, you can't use that feature on this implementation.
Right.
Potentially yet, it doesn't have to be forever, but at least now.
Okay. Yeah, that would be nice. I suppose if you have a number of implementations, being able to basically just kind of query them and find the one that has the thing that you actually want, then you. So okay, yeah, that's cool.
Multiple implementations is also a thing that we care about, and like, I guess I should point out too that everything I've just said is all in proposal stage. So just take take that with a grain of salt. That there's definitely some room for changes and reinterpretations, but the spirit of it is we want people to be able to very clearly see, and we're going to come up with a solution for that.
Yeah. I mean, it's as you say, kind of a lot of it is things that would be nice to implement, or kind of roadmap kind of features. But as is, a lot of people in the talk that I was giving last week at the Net DevOps days weren't necessarily users of Kubernetes, or were learning about Kubernetes for the first time. And when I was pointing out that a lot of things are usually either alpha or beta, even today in production, there's a horrified look across most people's faces. And I'm just like, that's just the way of the cloud native world, unfortunately. Like, most resources that people are using are still in kind of weird beta phases and things like that.
Yep.
It is what it is. Cool. So yeah, so like kind of the next level underneath the gateway class is the gateway itself, which is effectively your access into the cluster itself. And that typically is where things like IPAM need to actually occur, or the gateway needs to understand the infrastructure in order to attach addresses and things like that.
That's kind of, yes, it's kind of up to you right now. And most implementation, so we have kind of I would say a little bit of a dichotomy in that we have two very specific types of implementations that have emerged, or just archetypes. And that is cloud-based like implementations. Like for instance, my co-maintainer Rob Scott works on the GKE implementation of this, and in cluster implementations, which is like what I work on, with like a proxy actually in the cluster. And so to your point, it's basically a matter of most of the in-cluster implementations that I'm aware of today just use service under the like, that's just how it rolls, or that's how it kind of rolls out. However, that's not required by any stretch of the imagination. And yes, you could kind of implement something different if you wanted. That just tends to be it. And on the other hand, the like cloud level ones, their IPAM is based on like load balancers and GKE, that kind of thing. So
yeah, it's interesting. I was speaking with kind of and looking at some of the other implementations of it. The on-prem kind of implementations, you basically either jam some level of IPAM into the gateway controller, or you have to build some implementation between your gateway and an IPAM product like Netbox or whatever. Or in places like Equinix Metal, you would need to speak with the API of that and get a external IP address from their API, plumb that into your gateway, and then you can attach the routes to it.
Yeah. And we're trying to do some things too related to this. It's not going to happen before GA necessarily, and it doesn't really need to, because these are implementation details that the users really won't see much. But like one of the things that we think of as like a long-term major goal, and when I say we, I mean the maintainers, we've thought about this for years, is we'd like Gateway, the resource, to be in a position to replace service. Basically, you could not need a service involved for some use cases. Not I should be clear, not completely replace it.
Yeah.
I don't know if that'll ever happen. But as a SIG network chair, I can tell you that like between Tim Hawken and some of the Zappa and some of the other people that I work with at like the SIG network level, at the greater SIG network level, there is a desire to stay away from continuing to load onto service, like more features and stuff like that. It has become a very, very large API, I guess is probably the best way to put it. And so we're all kind of aligned in SIG network right now around this idea that Gateway will eventually be able to take over a lot of those use cases. So just that's on the horizon. It's part of the effort. It's not something that we have a lot of work for done yet, because we're trying to focus on the very user facing kind of stuff for the GA. But it'll be coming down the road. I think you'll be at a point where it's like you create a gateway, there won't be a service because all the facilities that you need will be there. So
that's very interesting. Is that I mean, should we get to that point, that's going to require Gateway API kind of managing the data plane to a certain degree. I mean,
that's what it does now for some implementations.
Okay.
Like the gateway operator that I'm working on at Kong, it's got a lot of different ways that you can do things, but the core use case, and it was demoed at Detroit. If anybody's actually interested, there's a demo of it at Detroit KubeCon at a talk I did with Rob. It is basically a gateway API driven. You create a gateway class, you get everything we talked about with gateway class. The controller says, yep, I'm going to be responsible for any gateways you create. When you create a gateway, you get a Kong gateway, it provisions it, and then there's a gateway configuration resource which you can attach, which will allow you to kind of change any of the underlying configuration bits of that data plane. So yes, in that sense, gateway is at the center of like driving data planes, and I think that's pretty common among implementations today. At least there are other implementations doing something similar. So.
Wow. Okay, that's very good. It's interesting, and it's very enlightening to a certain degree to find out where Gateway API could actually end up landing. Kind of, especially people have been using again with my Kubernetes head on. They've been using it since time immemorial, services and things like that. So having to kind of change their mindset to a certain degree. Obviously Gateway API will kind of need to evolve as well, because at the moment it still relies on services. You create a HTTP route or a TCP route and the backend ref.
That's the common way it shakes out. Yeah.
Okay, fantastic. And then so HTTP routes at the moment are the premier implementation of the I guess kind of the first official routes to be
as far as the route state. APIs go, it's going to be it's currently our intention for GA to just include that route in GA. We also have TCP route, UDP route, gRPC route, TLS route. The sky's the limit as far as routes are concerned. The ones that are the most mature one that's not HTTP route, I would say it was gRPC route right now. And then TCP route and UDP route are ones I kind of often work at like the L4 level. And so I'm personally focused on trying to get those going. There's hope to have those into a beta state for GA. But I think given just how much is left, the fact that we only have like a few months left, I think it'll be a little bit after, but just so people know, if you're interested in kind of the L4 use cases, they're coming. It's not going to be, they're not getting the same priority as HTTP route, because that is by and large the most popular one. But they are coming shortly behind. So
very exciting. I mean, so for people who are kind of using Cilium at the moment, we're expecting the TCP route and the UDP route to be added to those in kind of the next release or upcoming releases in Cilium soon. So like work is already being done on kind of adding those. And there's been a lot of other conversations in kind of some of the other kind of on-prem load balancers. So MetalLB have been kind of evaluating how they would implement TCP routes and UDP routes kind of moving forward to have that functionality.
Yeah, cool. So, and I saw the podcast or the eCHO not too long ago where the Gateway API support was like first announced. That's really cool.
Yeah, absolutely. There's I think we have created, well, when I say we, Nico and Raphael and others have created a number of fantastic labs all around Gateway API. So you can kind of jump onto one of these free labs, and you can deploy Cilium and deploy sample apps and kind of get your head around kind of what it kind of looks like. Because if you are used to deploying some pods and creating a service on top of them, and then just kind of connecting to an IP address, then that's fine. But Gateway API, there's kind of a few more kind of moving parts to it to a certain degree. So it is a little bit different. It's a different architecture, but I think, as you've mentioned, the clear delineation or separation of duties between who's kind of actually managing what. Because at the moment, who's creating the load balancer? Is it the application people? I mean, they're deploying the application and they need to kind of link all the parts together, but it's a bit, one person is basically almost in charge of the full stack, as it were.
Yeah.
Excellent. So, from your perspective, what's kind of the current state of Gateway API?
We are just about ready to ship that GA. We do have.
Oh wow!
I mean, like, we're close. Don't take that. Don't.
You heard it here, everyone.
You heard it here. It's going to release tomorrow. No, we're there's definitely a lot of smaller stuff left. One of the bigger things, that's something I'm working on with my friend Mattia, who works with me at Kong, actually, is called conformance profiles. We want to get that done. I'd actually like to talk about that a little bit, if that's not too much off topic. But it's basically a lot of the bigger stuff's done, and now it's kind of we're getting into managing kind of the smaller things and finishing up the one bigger thing that we have, and we should be good to go with that. Then obviously there's L4 and stuff like that should come not too long after into like a beta state. And there's a lot of GEPs, which again are our proposals. It's like KEP, Kubernetes Enhancement Process, but it's Gateway Enhancement, proposal. If you're interested, please do go to our website. It's under, I'll remind myself exactly where it's at, but I think it's under reference. Yeah, if you go to our website, it's under reference and then enhancement proposals on the navigation bar right on the left. And that should show you all the different proposals that we have going on and the state of them. There's different statuses, like provisional. It's similar to KEP. Lost my train of thought just a second. Let me catch up with it. So anyway, there's all these different proposals. We even have things like, I'm working with some people who work in like telco right now about potentially an egress use case for Gateway API, which is gonna, I didn't expect that to come around, I guess, anytime soon anyway, but it's like they're working on it actively. That's not going to be in time for GA or anything. In fact, it's kind of it's not going to move very far until GA is done kind of situation, just for sheer capacity. But in a few months, once we GA and stuff like that, things like that are probably going to start getting a little bit more gas and start moving. And so there's all kinds of interesting use cases. And you can see them all in our proposals, and you can bring a proposal to us. During the next few months, it might kind of go on hold a little bit while we're doing the GA, just a heads up. Like, you can still put it in if you'd like. There's a process for it, which starts with making a GitHub discussion. So please do make those. But just, expectations that like, we're only so many people and this is a huge project. So it's going to be a little bit before we get to the backlog of things for post GA. But yeah, there's tons of stuff to do. And, there's even like little weird things that we've talked about that aren't really kind of captured in a thing, but like are interesting to me. Like, we talked about the potential of having an IP route at one point and stuff like that. The sky is the limit, you know what I mean? It's not the limit.
Absolutely. Well, it is to a certain degree. I mean, there's a few people asking questions after I kind of did a demo of kind of the L4 stuff last week. And there were questions all around kind of like custom routes, a mirroring route where we mirror traffic that comes into a port. So for telcos who want to capture traffic that's actually going around, that TCP route that would be created would create a route to the actual pods, but it would also siphon traffic off to, kind of one of those intrusion detection devices that they have that monitor the traffic as well. There was also another query about generating a route that would basically encapsulate traffic as it was going on. So they wanted to do kind of quite funky stuff to like UDP streams and things like that. And could they create a custom route to do that? And I'm like, well, yes.
Cool.
You're going to need to write some pretty crazy eBPF code to do it. But I mean, the sky is the limit, as it were.
There's a really cool use case, Stunner, that only implements Gateway API with only UDP route for basically for WebRTC type stuff, which I think is really cool. So that's one of the L4 implementations right now that's kind of pushing for the maturity of like UDP route. Very cool how like, and there's also a really cool talk. I can't even remember all the details of it, but from KubeCon Amsterdam, if you get a chance to, if you're interested in Gateway API and just what can be done with it, I want to say it was a TV station in Denmark made a Gateway API implementation, and it was kind of amazing what they did.
Okay.
It just came together really good, and that was a really cool thought. I digress a little bit, but yeah, there's lots of cool stuff you can do.
It is that's kind of definitely one of the cool things about kind of the talks, especially kind of KubeCon. They do let's focus on kind of end user stories, seeing kind of the weird things that people are doing with kind of these projects. I've been part of kind of some of the stuff that telcos are doing, and kind of telcos always want to do kind of quite interesting things with their traffic, and it's kind of the same with that TV station. So yeah, it's one of the things that I think makes it interesting, being in the space, seeing the kind of sometimes wacky ways that that people want to use these projects. So as you mentioned, GA is hopefully KubeCon Chicago.
That's what we want, and it looks attainable. The big project that I'm working on finishing up for that, which I think is one of the few bigger things that we have to finish up, is conformance profiles, which I'll kind of gloss over briefly because I'm realizing what kind of time we have. But it harkens back to like where we came from, our roots in Ingress. One of the things that was really hard over the years was keeping track of the implementations of Ingress so that we could even mature it, like so that we could even bring them along for the ride and be like, all right, well, people are doing this, that, the other thing, so we will do this. Everybody just made annotations, and it was hard to keep track. Conformance profiles, the name might be a little mystic, but it kind of builds on top of our conformance testing suite. So we have a conformance testing suite implementations have to kind of, well, they should adhere to, and it's pretty straightforward. You can do it with like the CLI, a Go test, or you can actually inject it into a Go test suite if you're using Go for your project, and just run these conformance tests where it like creates routes and stuff like that and make sure everything works. Conformance profiles is this layer on top of that, which includes named profiles like that you can kind of subscribe to. For instance, HTTP. I do HTTP. My implementation does HTTP, and it does it at either a core or extended conformance level, which I didn't get into that too much, but again, that's all in the website, and it basically was the tiers that I was talking about. And you just say what you do, and you kind of run the test suite. But it also includes a reporting system, and I think this is going to be a very important thing for like the post GA world, and this is kind of at the core of why we care to have this in time for GA, even though it's a testing related thing, and that is, right now, the prototype that exists in the repository will basically run the test suite for you, given a named profile like HTTP, TCP, what have you. We haven't figured that entirely out yet, but more or less high-level named profiles. And the result, and this part works today in the prototype, is that you'll get it looks a little bit like a custom resource, but it doesn't have like type meta and all that. A conformance report in YAML, and that actually lists out exactly the results, and it lists out things like what features you support or don't support. So it's like a full report of like, here's the version that you used of Gateway API, here's the version that you used of your own project, here's all the results of the tests that ran, and we're going to have implementation submit those back to us. And this is going to change our world quite a bit, I think, because in the previous world, if you wanted to know kind of what features people were using, for instance, this is just one example of how we can use the data from these implementations. You want to know what features people were using, you queried Slack. You know what I mean? You're like, sometimes, hey, is anybody using this feature? Yeah, and it didn't really work. Now we will literally just be able to programmatically like go through our history of reports and say, okay, these features are in use, or we can say things like in the data like, oh, these implementations all picked up this new feature and started doing it at these versions. And so we'll be able to kind of do something that we weren't able to do with Ingress, in that we'll be able to actually see kind of an overtime data set of what is being implemented, what's working, it kind of exactly, so I digressed a little bit. That took a little too long to say, but yeah.
No, I suppose that's, one going to, could automatically generate documentation to a certain degree,
Yep.
matrices of implementations and what it is that they do. I suppose to a certain degree, it's also probably going to help with like the health of the project as well, to find out,
Absolutely.
how often the implementers of Gateway API are adding new features and what's really working and kind of what isn't working to a certain degree as well. So I mean, if you're seeing
It's
a
going
lot
to
of
keep
people,
us, very connected with our implementers, with the people who implement the API over time, very connected with them.
Yep, excellent, cool. So Gateway API, there's obviously a lot kind of going on. Where GA is in the near future. KubeCons are always up and coming endlessly, but fantastic. So kind of moving on a little bit. So you're part of Gateway API. You're a maintainer there. You're part of SIG networking. From your perspective at the moment, obviously Gateway API is going to be a huge part of kind of Kubernetes networking. What's kind of what else has kind of got your eye at the moment? What else is kind of exciting in kind of the networking space in Kubernetes?
Well, I kind of keep track of everything because I mean that's part of my post as like a chair. I'm kind of at least got my eyes on everything, if not deeply involved. And there's a few things coming down the pipeline. Like one of the things that I think is a little bit interesting right now is, and Rob Scott, again, one of my co-maintainers of Gateway API, he's one of the people working on it, is topology aware routing.
Okay.
Which is probably relevant to Cilium, but the idea basically, actually, no, I'm certain it's relevant to Cilium, but the idea basically just being like in the past, when you had something like, say, if you had a service and you wanted to route traffic between the various endpoints and stuff like that, you may not get an efficient topology, and we're adding some functionality that basically can allow you to kind of dig into that and maybe create efficient topologies or influence them or create. We called it topology aware hints before, if that helps to illustrate a little bit. So that one's kind of cool. We've got network policy is trying to get to a next big milestone, and actually I think they're going to be able to do that in time for Chicago.
Okay,
and
that's good.
Yep, they've got a lot of new stuff. There's admin network policy. And I go to all the meetings for all these, even if I don't like contribute directly to them, just to see what's going on. And so there's a lot of energy going on in network policy right now. We're working on Dan Winship over at Red Hat. Shout out to Dan, is working on kind of this. What's the right word? Just it's not. I wouldn't call it like a rewrite is probably accurate in some sense, but it's just like a revitalization of the kube proxy code in such a way that it'll be a little bit more consumable. We've had a historical issue in SIG network which actually it was actually one of the things that was like big on my mind over the last couple of years, worried about implementers like Cilium not having really a whole lot to work with in terms of like upstream giving them tools to implement like service.
Yep.
And so we've gotten into this situation now where I would say most implementations are kind of very disconnected from one another. There's not a ton of common ground. Everybody's kind of implemented in their own way. There's, tests and stuff like that, but I'd like to see us find some place to kind of nexus with each other on these implementations. It doesn't have to be everybody is like using the exact same machinery necessarily, but I would like to see us get to a point where some of that machinery is common, so that we just have a common ground where we're all connected and like staying together as a community as we go back to our individual implementations, instead of what I think it's a little more accurate to say right now that everybody's kind of doing their own thing.
It's always funny with kubeproxy. I mean, like I look at a lot of the CNIs and other such implementations that they've always literally fought with kubeproxy. I mean, kubeproxy is continuously programming the data path for pods and pod services and things like that. And then you've got kind of CNIs, kind of Calico back in the day had like all this kind of clever code to continuously keep changing what kubeproxy was doing so that it could insert its config, and then if kubeproxy would splat it, it would kind of keep coming back, and you basically just have these two loops fighting against one another. So I mean, hopefully some more intelligence into making kubeproxy a little bit more programmable would make CNI's lives a bit easier and things like that.
Absolutely agree. And I think we're taking the first steps on that road. I wouldn't say that is the current goal, but that is we're taking the first steps on that road. which I'm happy about. I'd like to see us come together a little bit more on like all these implementations, just so that we're communicating more, so that we can kind of make sure we're keeping a future where nobody's left out, certainly. And more importantly, I think than anything, users, we don't get. I'm not going to say how old I am, but I know you. I've followed you on Twitter for ages, but I know you were around in the time when like the Linux ecosystem, like implementations got really. There was a big disconnect, and you'd have like nowadays. I think we're finally back to the point where the Linux ecosystem is such that like you can't do everything that you can do on one operating system on the other, but things are more portable. But there was a time when things were just not portable. Like it was like if you were using CentOS, it was a completely different world than if you were using Gen 2 or something like that. It just I was a Gen 2 guy, and
okay.
for
Very
a long
cool.
time. Yeah, I switched to Arch Linux like 8 years ago, but I was a Gen 2 guy forever, and like nothing worked between that and like anything that you could do on Red Hat RHEL or something like that just didn't work, and it was rough. I don't want to see Kubernetes get into a state where we have like such big differences that it is like having a different distribution of Kubernetes to have a different networking backbone. Does that make sense?
And so absolutely. I think, especially for people who may, there's a lot of people who've kind of, to a certain degree, maybe only really had to do with kind of OpenShift. And as far as that's the bubble that they're kind of in, and it's always worked as expected. But if you're kind of going to be potentially dealing with multi-clusters that have different requirements and things like that, if they were to have kind of quite hard and fast limits, you're effectively going to have, as you mentioned, the distros of back in the day, where this Kubernetes cluster with this particular use case is only ever going to work in this way. And if you want to do something with that cluster, you're going to have to basically learn something kind of brand new. You're going to have to change your Fedora for a Ubuntu beanie.
That's a great way of putting it. You have to change your Fedora for something else, some other kind of hat. Yeah, and I'd like to get us to where it's close enough that you have to change a couple of things. You do have to know some things. We'll never be able to avoid. It'll never be perfect.
Yeah.
But let's get it close enough, and let's keep the community and the people implementing like connected enough that we stay together and like make it good for the users, so the users are not like in that situation. That's my motivation. So
excellent, fantastic. Yeah, cool. I I suppose some of the things that I've seen you kind of working on have been kind of heavily eBPF related as well. There's the is it Blix? Is that the name of it? Is that right?
Blix, yeah.
Yeah. So there's a lot of work that's been going in that. That's largely going to be for I guess is that the test harness for some of the TCP route and UDP route and gateway API.
Yeah, it started as just kind of just a blanket experiment doing eBPF. So like a year or so ago, so at Kong we have some eBPF in our Kuma mesh, and then we did some experimentation last year with just a bunch of different things. And one of the things that came out of it was this load balancer, wanting to do a load balancer originally with XDP, and it was fun. It was a good time, and it was meant to be a good time. Like it wasn't meant to be a product or anything like that, and that was kind of fun. Kong was like, "Yeah, go for it, give it a shot, see how that works." And we got to a point where it was functional enough where we realized it would potentially be, and we were implementing with Gateway API, like just because it made sense to. So TCP route and UDP route. So it got to a point where it was like, this would probably be a decent reference implementation and test suite, like test harness, basically for parts of Gateway API. So we went to contribute it to the CNCF, and it is unfortunately kind of still in that situation because of some. It is though. It's on its way. It's going to happen, but it's in some license. It turns out the GPL2. Because
I've been following this with feathered interest.
It turns out the GPL2 is actually a problem potentially for the CNCF, which is interesting. But the suffice to say, it is on its way to becoming kind of this reference implementation. And just in case anybody's watching this and is like, does that mean it's going to be like the Nginx ingress controller? No, we are absolutely actually against it ever being a production use case. We don't want it to be. We want it to be a testing and a reference implementation. It's something that people kind of use, for fun, learning, or to kind of model how they would build their own implementation of Gateway API. And so once it finally makes it over the hump, we'll plug it into our CI. We'll kind of clean it up and get it into a state where it's kind of like somebody could go and look and say, here's how you do a gateway API control plane. Here's how you implement some of these route related features, that kind of thing. And it was a lot of fun. And I did it with, I started it with my friend. I mean, we started at Kong, but like it really didn't take off until Andrew Stoikas at Red Hat, who actually works on network policy. And we kind of just took it and ran with it at KubeCon Detroit last year. And it's been, we've been running with it ever since. We just had a release not too long ago where we kind of have like the basics of like TCP and UDP route are kind of functional now. So it's really just a matter of getting that licensing stuff figured out and then plugging it in, and it should help to drive forward the L4 use cases to beta as well, because it will be one of the first implementations, along with a couple of yours, I think, which will exercise it. So
yeah, very cool. And it's in Rust. I couldn't help but notice your mug. I've never written any Rust with that. So, I mean, from people who are looking at writing eBPF at the moment, from my, I've written eBPF, but it's all been in strict C. What's kind of the Rust support like for? What's kind of the experience that people would normally get from writing eBPF in Rust?
Yeah, that's an interesting question. It's going to have a kind of complicated answer. A little bit of history on that one. So Andrew Stoikas, again, who's a friend of mine and works at Red Hat and helped with Blixt, is also working on a project called BPFD, which is effectively like a generic loader for BPF programs, where like you don't have to write, like for instance with Cilium Go, you would load your code with like your Go code and stuff like that. This was more like a daemon that'll run on the system, and the thing that I really like about it, and we're going to actually end up using it in Blixt for, is that it has things like Kubernetes custom resources for eBPF programs. So you can just like build your bytecode, put it in a container image, and then drop it into your eBPF program, drop it in your cluster, and it'll go load it on all your nodes. And that project uses Aya, AYA, which actually Dave Tucker, who's been on the show I think twice, is one of the maintainers of, and he also works on BPFD at Red Hat with Andrew. That Rust ecosystem was just kind of something we were already connected to. For like, I was helping out with BPFD a little bit over the last year, and Andrew and Dave obviously are deeply invested in it. And I've done Rust for a very long time.
Okay.
I started doing Rust when I worked at Basho Technologies, which nobody's probably going to know who that is, but we made Riak, which was a distributed key value store before the company unfortunately went out of business. And it was the first time I had done Rust, I want to say it was 2016. I probably started in 2015. I worked on the Riak client in Rust.
Okay.
And sorry, I'm going a little bit all over the place, but I wanted to give a little bit of like backstory here. So like where I started was probably 2015 with Rust. I worked on the Riak client, and the idea there was they had wanted a C client for Riak for like ever. There's actually a client's team. They wanted a C client, but nobody could really get around to doing it. Nobody really wanted to do it, but they wanted it because it makes it easy to like FFI your way from any other language. Like it would give people, for the clients that it doesn't make sense to put a lot of energy behind, it'd give them something to do. Rust can emit like C compatible object code, and so it kind of I threw it out there like, why don't I just write it in Rust? It'll be more fun. It'll get it'll get some attention just because of it's in Rust. And they're like, yeah, sure, go for it. And I did it. And unfortunately, the company went out of business before I got very far with it. But that was where it all started for me, and it was a lot of fun. And I've done Rust ever since. I've done Rust at every place I've worked since there. Not necessarily as my number one. I would say Go has kind of remained the number one, all things considered.
Yep.
So anyway, that I have a long history with Rust,
okay.
and then Andrew obviously has kind of like that in with Aya, and I have an in with Aya kind of already. So a lot of the reason it is in Rust is because that's what we're used to. I did see before, like for a long time in my career, and I am one. I don't know if I'm rare, but I'm one of the people who did see for a long time and doesn't want to do it anymore. it's just kind of where I'm at with it. Like I
Fair enough,
prefer not to, if I can avoid C. And there's reasons I think that we could say that we're, are somewhat obvious. But the other side of it was this was meant to be like an experiment and kind of a fun project that was like, I think low key is one way you could put it, where like people can come in and it's never going to go in production, so they can kind of feel relaxed a little bit about, contributing to it. And for better or worse, saying that something's in Rust right now catches people's attention.
Yeah, it does. Yeah.
So like all the stars aligned. So if you look at the history, the Git history, you'll actually see that it originally started in C. When it was like just purely just experimenting at Kong. But as people have joined in from the community and stuff, we moved to Rust for kind of all of these different reasons, which do include Rust is popular right now and gets people's attention. So there's a little bit of pizzazz to that. I will say that if for anybody who's just being completely, I guess, straightforward, anybody who's interested in doing eBPF code in Rust, it is a much harder path in some ways. There are some things that are doing really good, but like Aya, for instance, is doing well. I would say it's very active, but it's obviously not going to be like right on the libBPF is going to be ahead of the curve a little bit. So if you want to get involved in Rust, there's a good chance, like if you're doing like some simple stuff with TC, XDP, stuff like that, it'll be fine. And actually, it'll probably feel a little bit familiar in terms of like how the code is actually structured, because people will argue with me about this, but as somebody who came from C, I would say the Rust syntax doesn't throw me too hard. And
that's interesting.
Yeah, it doesn't throw me too hard. There's definitely a lot more syntax, but it doesn't throw me too hard. Maybe I'm biased because I've been doing it for a while. But the I'm starting to digress a little bit. But the point just being that like it is going to be a little bit of a harder road, but I think we're going to get to a point, especially with the help of projects like BPFD, which are helping to drive it, where in the next couple of years, it's really going to even out. And if you're interested in Rust and if you're somebody who wants to dig into like the deeper details of things, it can be really fun. I've had a lot of fun working with like Rust and Aya to do eBPF code on top of all the fun that it is to do eBPF. And I mean it when I say fun, like it's been a fun thing. There's definitely been
fantastic to hear is that
struggles, but it's a fun thing.
Yeah.
I maintained a kernel module like years and years ago. Right. And that was not
awesome prayers on that one. Though.
Yeah, that was not fun. And BPF, I'm not necessarily trying to draw the direct parallel that eBPF is like a replacement for kernel modules, or that it's, but in some ways it is. And, it's kind of similar. It's got some parallels and I like it a lot. I'm very happy and I appreciate the people that have put the effort in to do eBPF, especially as somebody who's done a kernel module. So
I suppose before we kind of wrap things up, like, one final question I thought that I had really was just setting up your environment to actually kind of start writing eBPF code. Like it can be, you need the kernel headers, you need libBPF, you need BPF tool for your particular kernel. Yeah. You need to generate some skeleton code for the headers to all work and things like that. From a Rust perspective, is that process much easier or automated, or is it still?
Actually, the build stuff is. Okay. So the guys, the including Dave, who worked on the Aya side of things, I would say the build stuff is really easy and benefits from, and this is probably one of the reasons why I like Rust compared to C, other than like memory safety and thread safety stuff that you get, is, I mean, it's the truth though, right? It's like there's some reasons to. No,
I completely appreciate that. Just going down that the points that kind of get people's backs up sometimes.
Yeah. But the I still write C, if that makes anybody feel any better. It's not like it's completely. But anyway, the I lost the question for a second there because I got distracted. The build ecosystem. So the build ecosystem, you benefit not only from the fact that Aya has put a lot of work into like doing like they have like a BPF linker tool and stuff like that kind of has a lot of automation for the build for you, but you also just benefit from what I think is one of Rust's it's one of its strengths is just its build system. Like it's with Cargo and Rust Up. There's just kind of the ecosystem. I should probably not just gloss completely over those. Cargo is a build tool that's kind of like an all-in-one kit for building your project. You should definitely go check that out if you're interested in Rust and see that, because even if like the syntax seems like the most important thing to focus on, the build system really matters. And then Rust Up is just like Rust's toolkit for kind of downloading different versions of Rust and kind of hosting them all on your system and easily switching between them, which is nice. But I digress, and I guess I didn't realize how far we were on time. But the long and short of it is the build stuff is the part I think goes really well right now. There are definitely going to be some hiccups. You know, it's an early maturity tool, but that part hasn't really been in my way. The thing that usually has been the problem is like, I mean, there's been a couple of things, but like this is probably important for people who know eBPF. It is not a wrapper around libBPF. It is a Rust implementation at the level of libBPF. So there's a lot of complexities with doing that, and there's some differences like with the Rust type system, which make that occasionally there's just weirdness that you have to get sorted out, and it gets sorted out. But those kinds of things, like just little, like there's been times when like we've had to deal with like memory layout issues and stuff like that with Rust, where IA doesn't guard you from it, and in the future it might, you know, but like currently it doesn't today, that have caught me. And whenever I have to look at the BPF verifier logs, that those are usually not the greatest days. Like those, I I don't mean that in any kind of bad way. It's just like it's difficult. I'm not an expert at eBPF yet. I'd like to be in time. But the BPF verifier logs, I'm starting to be able to kind of like really work my way through that. You know, having a background in kind of lower level programming has helped a lot with that. But it's still pretty hard. So
yeah, having a list of registers and various other bits and bobs is not necessarily the easiest debugging path for most people, I wouldn't think.
Yeah, it's difficult. But I think given how much energy I see on eBPF upstream in Linux kernel, and then you know the work that you guys are doing with Cilium, and even like there's so many projects doing eBPF now. I think it's just a matter of time before we kind of these things come together, and it goes faster if more people get involved. So do get involved in your relevant eBPF project if you're interested. You know, if you feel afraid of eBPF, don't be. I think a lot of us are. I mean, Dan just said BPF verifier can be scary, right? So like, don't be afraid to jump in and just kind of get started, and don't worry about the fact that like people are, you know, going to be like, oh, you don't know enough to get started in here. We're all kind of in the same boat. It's still, even though it's a few years in, it's still a pretty early project. And
it feels very early days to a certain degree.
Yeah.
It is fantastic to see it being used everywhere. I think for a lot of people who want to do it for the first time, there is a learning curve that's mountainous to a certain degree.
There's a steep learning curve, definitely.
Yep. But as you say, as more people, projects adopt it, that should be rounded off a little bit and make life a little bit easier for everybody.
Yeah, the more people join, the faster it'll go.
Excellent. Well, we're coming to the end of this eCHO session. If people do want to learn more about eBPF, I've heard of a summit that's coming up in the near future. So as mentioned, eBPF Summit, if you go to ebpf.io, all of the resources you'll find there. I'd like to give a warm thanks to Shane for sharing his journey, giving us an update into Gateway API, his thoughts on kind of what's happening around SIG networking and thoughts on eBPF, all things networking. So thank you ever so much for that.
Thank you very much. It means a lot to me to be invited on here. Thank you. I appreciate it.
Fantastic. And thank you everybody for watching. Thank you very much for joining this eCHO session, and we will see you all next time. Thank you very much, everyone.